Welcome to my channel AI Basics with AK. Here we are with another new episode in our season 3 introductory statistics on confidence intervals. In the previous episode, which is episode 7, we have come across a beautiful concept called central limit theorem. What does central limit theorem says? If we take independent sufficient samples, the distribution of sample means becomes normal distribution. This is very core importance because we can approximate any distribution to a normal distribution, not the whole population but the distribution of the statistics of sample means. So this is where we are actually identifying how much confident you are that this sample mean is this much value. So that's where this confidence interval comes. Say for example, you have a sample population of one class of say maybe 2-3 schools of one particular grade and marks, and then you are given to estimate what could be the average score in the given county or in a city. That's where this confidence interval space. So you take 2-3 samples or sufficient samples from different schools, and then you construct a sample mean and its variance. From that you try to estimate, okay, the sample mean, if I have to be 95% confidence or 99% confidence, it would range from this value to this value. That's an next step from we can dive in from an unknown population to an certainty, like we don't know what is an population of the entire city. So that's an uncertainty. From that uncertainty, given a sample, we are arriving at a certain solution with a given confidence. What is that confidence? Okay, how much confident we are. Like, is it 90% confident, 97% confident, or 99% confident? So given the confidence, okay, what could be the average statistics, could be the average statistics of the population. That's where that's the science behind this confidence. Now here, that's what we are trying to see. This becomes the foundation of inference because we are given an unknown distribution and we are trying to inference based on a sample statistics. So the larger sample yields give more reliable confidence intervals, because the more data we see, the more confident we get about a sample mean or a sample statistics. Beautiful, right? So this is a distribution of a sample mean. When I'm saying confidence, okay, how much confident this mean is between 0.8 to 0.2, how much confident you are that this mean is between 0.4 to maybe 1.8. If it is more wider enough, you can say that, okay, I'm 100% confident or maximum percent confident. If you want to arrive, okay, maybe a single point statistics or a very thin margin, you become very less confident because there could be a possibility that your sample mean could also fall in this range. That's the confidence intervals you are trying to arrive at. Like, okay, I'm 50% confident, okay, the mean might be between the range of 0.8 to 1.2. Okay, maybe I'm 99% confident that the sample mean or a sample mean ranges from 0.4 maybe to 1.8. You might be thinking, it's too wide, right? Yes, it's too wide. But if we take more sample means, like here the sample distribution is only 30, if we have sufficient samples, this distribution becomes much more thinner, okay, and like this, and it becomes much more sharper for our prediction or for our inferences. So let's introduce the what is confidence intervals. Confidence intervals provides a possible range of values of an unknown population parameter. They quantify the uncertainty. The word is actually the uncertainty of a sample estimate. What we don't know about the scores of a population, which is maybe in a county or a city. What we are trying to estimate, we are taking samples and then we are trying to estimate it given our confidence. A confidence interval gives an estimated range of values, which I have discussed in that. For example, 95% confidence interval means if we take repeated sampling many times, there is a chance that 95% would be the true parameter. That's the actual definition, kind of a thing. Make sense? Now, it's very simple, right? Like, even if it is 90% confident or 95% confident or 99% confidence, you have a point estimate. It means what could be the central most possible sample mean, which is what we could see it here. This could be your central most mean, and the confidence is nothing but this is your margin of error. Whether you are 90% confident or 95% confident or 99% confidence, is this dispersion from your sample mean, which looks like your standard deviation altogether. So that's what it is here. If you can see the definition, the point estimate is usually the sample mean or a proportion, which is a central point. Margin of error reflects your variability and the confidence level. So how do we calculate it? Margin of error. It looks like okay. Let's forget about all these things. It simply looks like okay. A population standard deviation or a sample standard deviation. Here, what I'm trying to tell, as per statistics, is that if you have a population standard deviation, you can use it directly. In most of the cases, in real world scenarios, we will not be having the population standard deviation. In most of the cases, we'll be using a sample standard deviation, and that's the reason most of the times we would be referring it to the t-tests. We will be exploring all these t-tests and t distributions in the further episodes. So confidence intervals are more than just ranges because it gives you the uncertainty and trust in the data if you have more samples. Larger samples leads to a narrowing of intervals. Make sense? So that's more about it. So here, okay, I'm leaving this slide to you for you to play around. Like how do you, if you start increasing the samples of varied distributions, how narrower the confidence intervals becomes. So that's it for this episode. We'll meet in the next episode. Thanks a lot. See you soon.